All right, the main thing to remember with exponential decay is the two models that we use to look at it, to quantify it. F of t is equal to f naught of e to the kt, where f naught is our starting value, k is our exponential decay constant, t is time, and f of t is how much of that substance remains after t time. We can also look at this model in this form where we divide both sides by f naught, and this gives us the fraction of what's remaining after t time. This format will be useful, especially as we look at half-life. So let's tackle that. Find the half-life of a radioactive substance with decay constant K is equal to negative 0.001. Give your answer to 3 decimal places. Always be mindful of that. What does the half-life of a radioactive substance mean? It means the time it takes for that substance to decay to 50% of its starting quantity, meaning that we want to look at this fractional form of our equation, and we want to know, when is this fraction 0.5? When we know k, what t gives us 0.5? So let's write that out as an equation. We know k is 0.001. We want the fraction to be 0.5. We need to know what t is. So in other words, we're solving this equation for t. Now, how do we do that? Well, the issue is our e. We can't mess with this power very much without getting past that e first. So let's take ln of both sides. The natural log is, in other words, the log base e. We'll get rid of that e. So we take log ln of both sides. We get ln of 0.5 is equal to ln of e to the negative 0.001t. Remember, of course, that ln of e to the a is a. So ln of e to the negative 0.001t is just going to be negative 0.001t. Again, we're solving for t, so what I'm going to do is I'm going to divide both sides by 0.001, and we end up with t is equal to ln of 0.5 divided by 0.001. At this point, we involve the calculator. And the thing I want you to be mindful of here is as we type it into a calculator, finish that parentheses. This parentheses is so very crucial. But you should write it something like this. I would advise you to do this yourself to get you some practice with your calculator, because you should end up with this number we see here, 693.147 years. And that is the half-life of our radioactive substance. Let's look at another example. We have 100 milligrams of that same substance. How much of it will remain after 350 years? Approximately half of our half-life. Again, give your answer to 3 decimal places. Here, what we want to do is we don't want to use the fractional form because we're given an exact quantity here. So we want an exact quantity as our answer. So we're going to use this format for our model. F of t is equal to f naught e to the kt. What are each of these variables? We know f naught, that's our starting quantity, which is 100 milligrams. So f naught is 100 milligrams. We know our k, that's from our previous problem, is 0.001. And we know our t, because we're looking at how much will remain after 350 years. So our t is 350. So here we have a simple computation. What is f at 350? And here, once more, we're going to use our calculator. Again, I will always encourage you to be mindful of how you write things and be mindful of your parentheses. It should look something like this. And again, worth the practice on your own. Check and see that you got 70.469 milligrams.